Okay, so 2.5, implicit differentiation. You have been working with your differentiation rules, and now we are going to do implicit. So far, everything has been, all our variables have been like one variable, correct? It's all been like X or T or whatever. It's always been those. Now it's not. Okay, so the difference between the two. So implicit is here, explicit is here. So what's the difference between those two?
X and Y are like together.
Right.
Go ahead. It's not at the bottom.
Right. So X and Y on the implicit are being multiplied, and it's not Y equals X. Okay. So explicit is what you have been doing. It's Y equals, or it's one variable equals the other. And we have been doing, on explicit, we've done dy over dx. And I don't know if you remember or not, but that says the derivative of y with respect to x. So that's what that means. So the derivative of y, which is the equation with respect to x, because x is the variable on the other side of the equation. Does that make sense what this dy dx means? Mm-hmm. Okay, so then we've taken the derivative. So when it's different, we solve for y, we can use the implicit, and we don't want to solve for y, we can use the implicit different definition. I can't talk. To do a differentiation, we will take place with respect to x, meaning the different terms. I kind of explained it there. So when it's not solved for one variable, then you have to use implicit, and you still don't know what implicit is, and that's okay. So we have variables if the variables agree. So d dx. So we're taking the derivative with respect to what variable? X. Is x the only thing on the left? Yep. Yes. So then we would take 3x squared. Yes? Okay. d dx of y cubed. Do the variables match? No. So since the variables do not match, and people watching videos cannot, this variable and this variable do not match, we have to do it this way, the next way we're going to do. So you still take the derivative of y cubed, so it's 3y squared. Mm-hmm. Got it? But then we have it times dy dx. Now, dy dx means derivative, yes? Okay, so we have the first rule that we've been using. So you would use the rule just like any other time, and then you multiply it by that derivative. That has to happen anytime these two do not match. Now, you can write it like that. You can also write it as y squared, or 3y squared y prime. What does y prime mean? dy dx. Just this is the same thing as this. Okay, so whichever way you would prefer, usually people start with dy dx and they move to just y prime. If you look, like if you go to the derivative calculator, I think they used y prime. I'm just saying, I think they do. I'm not 100%. So we still need to do it. Okay, so we have dy dx. I'm going to give you a chance to write it down. How are these? Just a second. Oh, that was AB. I did them for you. Okay, CD. dy dx of x plus 3y. So this says we're taking the derivative of this stuff with respect to what variable? X. Okay, so anything with an x we do normal. So what's the derivative of x? 1. I can't even think. Okay, plus. Now, y, we have 3y. Y does not match our x, does it? No. So we have to take the derivative of 3y, which is 3. But then we put dy dx after it. So it's 1 plus 3y prime if you want to write it that way. This is 2-5. So the next one I have is dy dx of xy squared. Okay, so xy squared, what derivative rule would I need to use on that? Product. Okay, so the first function is x, the second is y squared. So the same things apply. So the product rule says f prime g plus f g prime, correct? Mm-hmm. Okay, so we're going to do the same thing, but when we take the derivative of the y, we have to put dy dx after it. Okay, so the derivative of x is 1, and then times y squared, plus x times, and the derivative of y squared is 2y, and then dy dx. And again, why do I have to put the dy dx right after it?
There's no respect to it.
There's no respect to, yes. The variables don't match. So I can rewrite this as y squared plus 2xy y prime. If you need to keep if you need to write y squared plus 2xy dy dx, that's perfectly fine also. It just, to me, it looks cleaner. I like it better. When you see y prime, should you think dy dx?
Are we gonna do anything with that? Or will it always just be y prime?
Well, we will eventually, it will say you would eventually solve for y, give me a minute. Okay.
X prime mean?
X prime?
Yeah.
Well, x prime is 1.
No, I mean if we were paying respect to y.
Oh, okay. So if we did the same problem as derivative of x with respect to y.
So just be that.
So no, it would be written like this. Okay. So then, what's the derivative of x? 1. So it'd be 1 dx dy times y squared plus x, and the derivative of y squared would be 2y. So we would have y squared, well, you'd have x prime, sorry, because you got to put x first, right? Plus 2xy.
Wait, we put it on the derivative when we do it?
Yes, because that's what it means.
What does it mean again? The derivative?
dy dx means the derivative. The instantaneous rate of change, the slope function of the function. Okay, so the denominator tells you what variable you can differentiate without having to put, okay, can there be more than 2 variables involved?
Yeah.
Yes. Any variable other than what is being derivative with respect to has the derivative after it. Okay, guidelines for implicit differentiation. This is on page 145 in your textbook if you want to spend some time with it. Okay, so differentiate both sides of the equation with respect to x. That's when we have an equation. Okay, we haven't had an equation yet. I've just given you an expression. Okay. Collect all terms of dy dx on the left side of the equation and move all other terms to the right side. That's what you were asking, and I said, give me a minute. Okay, so until right now, you've only had expressions. You haven't had equations, so there was nothing to do with it. So now we're going to have equations. So we're going to differentiate both sides with respect to x. We're going to move the dy dx or the y prime or the derivative of y to the left. So the dy dx is going to go left and everything else is going to go right. Factor dy dx out of the left side of the equation and solve for dy dx. When you are done, it is going to say dy dx equals. Okay? So again, you got this page written down if you want to spend some more time with that. 145. Okay, so find dy dx given y cubed plus y squared minus 5y minus x squared minus 4. Okay, so our rules said differentiate both sides in terms like dy dx, right? With respect to x. So you're going to rewrite it as, okay. Don't know why I just did that.
Your whole slide disappears.
I know. That's where we're at, right?
Yeah.
Okay. So, now it went. Oh. I'm clicking the right and it's like doing all sorts of funky stuff. Okay, so dy dx of y cubed plus y squared minus 5y minus x squared equals dy dx of negative 4. Okay, so differentiate both sides with respect to x. So we set it up. So the left side, we're just going to go through each term. There's no product, quotient, chain rule going on, but those will happen. You just have to identify and do them. Okay, so what is the derivative of y cubed with respect to x?
3y squared.
So 3y squared dy dx. Why does it have to have the dy dx after it?
Can we put y prime now?
We can. I want to do one problem with it there. So you could, because the directions say, like the directions on page 145 say dy dx instead of y prime. So if you go back and rewrite that, rewrite it as y prime. Okay. So I just want to do one so you can see it. And again, why is it dy dx? Because the variables don't match. Okay, so then plus
2y dy dx.
2y dy dx. Again, why is it dy dx after? Variables don't match.
Negative 5 dy dx.
Negative 5 dy dx.
Negative 2x.
And negative 2x equals, what is the derivative of a constant? 0.
You put dy dx?
No, because there's no variable.
Oh, right.
The derivative of a constant 0. There's no, it's 0 times dy dx. If you would put it there, it's still 0. But there's no variables, so there's nothing not to match. Okay, so the next step was to move all the dy's to the left and everything else to the right. So what do I need to do?
Move your 2x to the right.
Move the 2x to the right. So I have equals 2x. Okay, I'm not going to rewrite everything else because I don't want to.
Well, I am.
Okay, I'm going to do this in one step. Okay, if you guys are writing it, I guess I will. I usually do this. I usually do these two steps at one time. Oops. Okay, so the next step said factor the dy dx out, correct?
Yep.
Okay, so if I factor out dy dx, I have what?
3y squared plus 2y minus 5.
And then it says solve for dy dx. So these brackets are times, right?
Yeah.
So then what do I do to solve?
Factor.
Find the derivative.
No, we found the derivative already. Okay, guys, it's dy dx times this. I want dy dx on its own.
Goodbye.
Divide. Thank you.
Oh.
So I get 2x over 3y squared plus 2y minus 5. So I have found the derivative through implicit differentiation because we didn't have matching variables. The denominator did not match the variables, correct? Now, if I were to ask you the slope,
Don't.
I need an x and a what?
Y.
Y. If I were to ask you the slope, I need both an x and a y.
Don't ask me the slope.
You will be asked the slope. Questions before we move on to the next example? Now, I will tell you I do this and this on the same step because I can move this over and factor that out at the same time. But you can do two different steps if you want.
Wait, why do we like divide at the bottom?
Because
What's going on there?
because this is
It's
multiplication.
already being divided.
Oh, see, I get a bracket, or I get those.
If you need to use parentheses, use parentheses. I use brackets when it's big stuff, like a bunch. That's just how I
Brackets look cooler.
I use my brackets because I don't like big parentheses. Bugs me. But they mean the same thing. Yes. Okay, so now find the slope of the tangent line.
Already?
Already.
You only gave me one example, girl.
Well, we still got to do the same thing, right? So in order to find the slope, I have to find the derivative, and then I have to plug things in, right?
There's way too many steps.
No, it's the same steps over and over. Okay, so what do I do first?
Let me write down the problem.
Yeah.
Yes, write down the problem. Awesome. Yes, that is always what you do first.
Do those parentheses bug you?
Yes. But those have to be parentheses because it's a point. You can't put brackets on a point, then it would be an interval. It also bugs me that that's not negative square root of 2 over 2. A
That
lot.
doesn't bug me at all.
Okay, so what do I do next? What?
You dy
Put it out.
dx.
You set it up.
So dy dx of both sides.
Yeah.
Now, why is it dy dx? When could it be dt of dx?
When there's a t in the problem.
When there's a t in the problem. Good job. Okay, now we do have to use the brackets on this one because we're actually performing that operation. We are not multiplying. Equals dy dx. 4. And I'm going to tell you, they're not always constants on the right. They're not always constant on the right. It just happens to be. Okay, so you're taking the derivative now. So 2x
2x
plus
8y dy dx.
dy dx, or Cadence asked if we could now use y prime.
Yeah.
Okay, so dy dx is equivalent to y prime. Yes?
Because look, we can have like y prime equals.
Mm-hmm.
Well, okay.
Yeah, because in our problems, we put y prime equals all the time, don't we? We do dy dx tells me I have to find the derivative, and when we're done, we say it's y prime. So, okay, so what is the derivative with 0? Okay, so what is my next step?
Move 2x over.
Okay, so 8y prime equals negative 2x. And next step is to factor out y prime, but there's only one term, right?
Yeah.
Okay, so then I would skip that step.
Divide.
Divide by,
Y prime.
nope,
8y.
8y. We want y prime equals. So y prime equals negative 2x over 8y. Hopefully we're reducing to
1, 4.
negative x.
Hey, why'd you
Oh, I guess, yeah.
get rid of y prime again?
I didn't get rid of y prime. It's right here.
No, but like on the right of the 8y.
So we took it out. We're factoring it out.
But she said we were gonna skip that step.
No, we didn't skip this step. We didn't skip the step because it's already done. It's only one term. There's nothing to factor it out of.
Yeah. Come on, Cadence.
I wanna get
Keep
it.
up.
There's a, like, we didn't skip the step. The step's just basically done because there's one term. Okay, then we reduced. So now we find the
Ah.
slope. So slope at square root of 2 minus 1 over square root of 2 equals negative, what's x?
Square root of 2.
Square root of 2. And 4 times y, which is
The negative 1.
over the square root of 2. You don't want to say it because you don't want to deal with it. But we got to deal with it. Okay, negative and a negative is a
Positive.
woo woo. Okay, so I hate that I'm going across. I do apologize. So I now have the square root of 2 over 4 over the square root of 2. So what do I do when I divide fractions?
Multiply by a reciprocal.
So it's going to be times square root of 2 over 4.
Yeah.
And square root of 2 times the square root of 2 is
2.
2. So 2 over 4. So the slope is 1 half. Yeah, right next to the hand sanitizer. Okay, so it's 1 half. Now, my question for you is, what happens if they only gave me an x? What if they just said x equaled the square root of 2?
Then we gotta find a Y.
Then you got to find the y. How do you find the y? You plug it back into which one?
The beginning from
The original. And in this case, you'd have to do a lot of math because then you'd have the square root, wouldn't you?
Yep.
You'd have to subtract x squared, divide by 4, and then take the square root of both sides.
Well, good thing that didn't happen.
Okay, so, but it could happen. So I just want to, remind you, if they only give you an x, you have to plug it back in. And why did we have to have a y?
For the bottom, we have 2 thingies.
Because we have x and y in our slope formula, don't we? Okay, so really the process after this point is what we've done before, but the equation has an x and a y. That's the only thing different. We're still finding the derivatives the same way, but when the variables don't match, you have to put the prime behind it. Okay, when we're talking about matching, we're talking about which variable? The denominator variable. Okay. Okay, so determine the slope at 3, 1. So 3 times x squared plus y squared, quantity squared, equals 100 xy. So I told you they weren't always going to equal a constant, correct? So guess what it doesn't equal?
A constant.
A constant. Okay, so you guys tell me what's going on.
Do we have to do the chain rule now?
Mm-hmm. Yep. How do you know you're gonna have to do the chain rule?
Because the function and the function.
You have the function and the function and the function and the function and the function, right? And actually, it's a chain product because of the what? 3. But what is the derivative of 3? 0. So when we did the f prime g plus f g prime, oops, that's a prime. This whole thing would turn into 0 because that is a constant.
This is when you're going to lose me.
Okay, well, I'm just saying, do you want me to go through it like exactly what it is and we show that 0 so you can see what would happen if that was like a 3x? Okay, that's what I was asking. And I wasn't asking it very well. Okay, what do I do both sides?
The dy dx.
Okay, so dy dx, make sure you have room to expand, of 3x squared plus y squared squared equals dy dx of 100 x y. Okay, so on the left we have product that has a quotient inside of it. So we're gonna do that all. So derivative of 0, because that's your f, is what? Derivative of 3 is 0 times x squared plus y squared squared. Okay. So plus the first thing, which is 3 times 2
x
squared
plus
y squared to the first, right?
Yes.
Times, now be careful here, because there's 2 terms in here. We have to take the derivative of both. So derivative of x squared is 2x plus the derivative of y squared is 2y y prime. Again, why is it the y prime? Because the variables don't match. Equals, and I personally, some people work the whole left side and then work the whole right side. I'm doing the derivative. I'm going to keep doing the derivative. Okay, now I have another product again, don't I?
Yep.
So I have 100x times y. So the derivative of 100x is 100. And then y plus the first term, which is 100x, times sorry, there's something on my screen and it's bothering me. And it won't come off. Okay, times what?
Y prime.
Y prime. Did you guys need me to write the 1 y prime, or are you good with me just jumping? What?
Y prime.
Okay.
Is that a bracket or parentheses?
It's nothing because it's just y prime.
Okay.
I was going to write 1 y prime because the derivative of y is 1 and then you have the y prime. Okay, so on the right, we're all good. It looks nice and neat. On the left, it does not look nice and neat, does it?
No.
And we are going to have to do some work with that because we're going to have to factor out the y prime. So we're going to have to do some work. We're only going to do what we have to do. We're not going to just, if we have to multiply it all out, we have to multiply it all out. But if we don't want to do that. So this first stuff, I'm going to change colors, so hopefully that will help. This first stuff is just what?
0.
0. Woo. Don't have to worry about it no more. Let's see. 3 times 2 is 6.
I'm not writing until you do.
I'm just thinking. So 6.
Y prime.
No.
No.
X squared plus y squared 2x plus 2y y prime. And I personally do not keep writing the right-hand side. Just like a proof, we just bring it down, right? We just know it's coming down. So again, can I get this y prime out of there? Can I factor it out?
No.
No, because like it doesn't work. So in order to be able to get to it, what do I have to do with all this first?
Times it all by y prime.
Well, I have to FOIL, don't I?
Right.
Yeah. And this 6 will go with the x squared or the y squared. See that?
Yep.
Jaden, Ainsley? The 6 goes with the x squared and the y squared?
Yep.
Okay. So I have 6x squared plus 6y squared times this. We're going to multiply those two out.
That's so bad.
Just stop. Okay, you do it and I'll do it because when I do it, I mess it up.
Wait, the y prime stays with the 2y, right?
Yes.
Like that's
2y, y prime is one thing.
that stays together.
Yep.
Okay.
Oh, I almost gave myself enough room. I didn't line up my equal sign. That
No
bugs me.
way I got that right, Miss Smith.
Did you get it right?
Yeah.
Ooh. Well, unless I did it wrong.
Probably more likely.
Jaden, did you get the same thing we did? Okay. So, could I have divided by 6 before I multiplied it all out? Could I have divided this side by 6? The right?
I don't
Like
know,
both?
60 or 100?
Okay, that's my point. If this was a 5, would I have divided before I multiplied?
Yeah.
Yes,
Probably
because 5 goes into 100, doesn't it?
Yeah.
If it was 20, would I have divided before I multiplied it all out?
Yes.
But 6, we're not dividing because it's not nice, is it?
No.
Okay, so now it says move everything, all the y primes to the
Right.
left and everything else to the
Right.
right. So we're going to move that to the left. Let me switch colors here. Oops, I needed an eraser, not a marker. So we're going to move this to the left, and we're going to move this and this to the
Right.
right. Okay, did you guys get what I did?
Yep.
Okay, now what?
Take out y prime.
Factor out y prime. And guys, honestly, I don't ever even show this step right here. When I move it over, I factor it out.
I can't.
Okay.
I have to do that.
Okay. If you get to that point. Okay, I also will suggest you put your y prime in the front.
Yep.
Because you're going to move everything else, right? So we should have what? 12x squared y plus 12y cubed minus 100x. And then so y prime is going to equal give you a different color again. Next step is to do what?
Divide.
Divide. So 100 y minus 12x cubed minus 12x y squared over 12x squared y plus 12y cubed minus 100. And we so wish that 12 went into 100 evenly, correct?
Yes.
But it does not. So what goes into 12 and 100?
4.
4. So can I take a 4 out of everything?
Yeah.
Do I have anything else I can take out? Nope. Okay, so that gives me...
We still do the dumb slope.
Yep, we still have to do the slope. So it still gives me... I'm going to write it in the right order because it's bugging me. So 3x cubed minus 3xy squared plus 25y over negative 25x, nope. X squared would come first, wouldn't it? So 3x squared y plus, I'm going to stop talking.
Excuse me, is Dave Allen?
Yes,
If you ever come to the office, they should be leaving.
sure. Thank you. Do you want to stay till we finish this? We're almost done. No? Okay.
Why is it not plus?
Because I'm putting it in the back in the order it should be. Because I can't handle it the other way. Have a good weekend, Jaden. We'll see you Monday. Okay, so now we have the slope. This is the slope, yes? Well, this is the slope function. Yes? So, how do we find the slope overall? Plug in
Plug those x's and y's.
x's and y's in. So, negative 3 times 27. 3 cubed, 27.
Yeah.
Minus 3 times x times y squared. 1 squared is 1 times 3 is 3. Plus 25. Over 3 times 9. Minus 75. Plus 3. And again, I just plugged in x's and y's. So 3 times 27 is 81. Minus 9 plus 25. And then 27 minus 75 plus 3. Can I erase some of this stuff up top?
Yeah.
Okay. I should have started up top. Okay, so I'm going to rewrite. So I've got m equals negative 81 minus 9 plus 25 and 27 minus 75 plus 3. Have you worked it out yet?
No, I want you to do that.
I got negative 90 and 25. That would be 5, negative 65. And then negative 75 and 30, positive 30. So negative 45. So m would equal 13 over 9. Yeah?
Yeah.
Okay. So that's the worst of it. Now what if it asks you for y double prime?
I'll cry.
You'd have to take the derivative of what? This?
Sure.
Which would mean you would have to use the quotient rule?
Or the derivative calculator.
When they ask you y double prime, it's a little easier problem. And look what I got.
Y double prime.
Yep.
Of course.
Okay, so find d2 d squared y over dx squared. I can't say that. That's like, find the second derivative. That's what that says, right? Okay, that is our last example. So hopefully if we do not have time to finish it, I will finish it and post the video. Oh, because we have 2 minutes.
Let's not even start it.
Well, we do need to do it though. Okay. I'm gonna just do it and you watch. How about that? I will talk my way through it. Okay. So dy dx of both sides. So I get 2x plus 2y prime equals 0. Subtract over the 2. So 2y prime equals negative 2x. So y prime equals negative 2x over 2y. So it equals negative x over y. Okay? So then we do what again?
Take the dy dx.
Dy dx and dy dx. Okay, we have a problem. We need the derivative of y prime, but we don't know what y prime is, do we?
No.
So y prime was negative x over y. Well, don't we have an x and a y?
Yeah.
Okay, so we plug it in. Negative and a negative is a positive and a 4. So I have dy dx of 3/4. Oops. And dy dx of this. But this is going to have to be quotient rule.
What about your negative 2x over 2y?
I reduced it to this. Like this doesn't.
Oh, okay.
Okay. So this is 0 on the left. So here I would have negative y minus negative x y prime over y squared. Oh, yes, y squared. So I need to multiply by y squared. 0 times y squared would be 0. So I have 0 equals negative y plus x y prime. So add y. So y equals xy prime. So divide by x. So y prime, oh, actually that would be double prime, wouldn't it? Yes, because we took the derivative of that. Would equal y over x. And so y double prime would be 4 over negative 3. So negative 4/3. Okay. And you'll probably have to rewatch that, but I wanted to